In this next little section, we're going to make a probability distribution. So my first probability experiment is a coin tossed 2 times, and we're going to let X represent the number of heads. So all of the possibilities, let's go ahead and make a sample space so we can look at the possibilities. So if I toss 2 coins, it could come up heads. My first coin could come up heads or tails, and then my second coin could come up heads or tails. So if I write a sample space, it could either be heads, 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 tails, tails, heads, or tails, tails. So this is my sample space. So my probabilities are the probability that none of the tosses are heads, and that would be 1/4 or 0.25. The probability that just one is a head, that happens twice, so that's 50% of the time. Or the probability that both of them are heads, and that happens once, so that's 25%. So I can check, make sure it's a probability distribution. Everything here is under 1, but greater than 0. It could also be 0, actually, but total those together, and they do total to 1. So that's the probability distribution for this particular scenario. So now let's look at this one. A 6-sided die is rolled. Let X represent the number that is rolled. So in this case, a 6-sided die has 1 through 6 on it. So my probability is, you know what? I shouldn't have, I'm sorry. I should not have done this. It should have been 0, 1, and 2. My X values here should be 1, 2, 3, 4, 5, or 6. Because those are all of the things that could appear on a dice. They would appear as dots. Well, most of the time. I actually have some dice that have numbers on them. So the probability of rolling a 1 is 1 out of 6, 1/6. So you can write it as 1/6 if you want. Probability can be a fraction, or you can write it as the decimal. If I write it as a decimal, it's 0.166666, so it would be 0.167. All of these have the identical probability. There's a 1/6 probability of rolling each one. So because I'm rounding up, I'm not sure if that's going to 0.167. Yeah, it comes out to be a little bit more than 1, but it comes out to be like 1.002 or something like that, but it's okay. It's the probability sums to 1. Those are my probabilities. And that's my probability distribution because each one of these is between 0 and 1, and it sums to slightly more than 1 because I rounded this end. And again, you could have written it as 1/6. That works. 1/6 plus 1/6 plus 1/6 plus 1/6 equals 1 exactly. So in that case, it would actually come out to be exact. All right, so now we're going to draw a probability histogram. It's a histogram in which the horizontal axis corresponds to the value of the random variable, so your X column, and the vertical axis represents the probabilities. So in this case, our probabilities are done as decimals. So we're going to have to scale this. So let's see, I'm going to scale by 0.05 to try to get, so my smallest value is 0.01, but my largest value is 0.58. So to try to get everything on there, I think that's going to work best. Quite make it big enough, but it's close. All right, so my first value is 0, and it's 0.06. So let's see, that would be right about here, and this is going to be 1. So, so we'll make this 0, and it's going to be 0.06. The next one is 0.58. So oh, go back here. And 2 of these would be 0.22. So y'all just pretend that this is perfect and that I used a ruler and made it look nice. 0.10. 0.03. So there's your histogram. Draw a probability histogram of the probability distribution, which represents the number of heads when 2 coins are tossed. So we did this one at the top of the page. Remember, it was 0, 1, and 2 is 25%, 50%, and 25%. Now there's a very important reason why they want us to do this one. I'm sure you'll catch it when we get it on this page here. So let's go ahead and do this one by point ones. So let's see, 0.10, 0.20, 3.0. Alright, so first probability is 0, then 1, then 2. First probability is 25%, so that would be right here. Second probability is 50%, so that would be right here. And the third probability is also 25%. So if you look at that now, pretend mine is perfect, which would have, they would be the same width, which that was terrible. But what you can see is it is symmetrical, or it is bell-shaped, which makes this a normal distribution. So we'll talk more about that a little bit later, but that's the probability histograms.